My name is David Alsoon. I'm the CEO and founder at Realize. Last year I came up here and I showed off some of the tools that we've been working on. I got a new one to show you guys now as well. This is something called Mo Replay that we're making available to everybody. And hey. So what Mo Replay does is we've had this tool for a while, and we're now opening this up so everyone can start to use it if you want to. A problem we've always seen is that live versus VOD, way more complicated. Problems that happen live don't happen in VOD. How do we deal with that? A lot of times we're having to spin up live streams all the time. We wanted to create a tool that allowed us to take a VOD stream, replay it as live. So we could take a recording from a live event, redo that without having to have an encoder and all that type of stuff. There are some things that have done this in the past, but they didn't do it as complex as we needed it. We needed to handle things like token authentication, now also working with CMAF, external audio, all these things that come into play. Be able to control rolling DVR, be able to have multiple users see the same stream synchronized, looping, and also be able to specify start time. So we put together this tool. We've been using it for a while. We just added a bunch of new features to it, and we figured it's about time to actually start sharing it a little bit more. So when we look at this, it has basic API. You pretty much just can just point to our host server. You specify what manifest you want to replay. If you want to loop it, if you're doing token authentication, you can supply it a token. Give it a start time if you specify a DVR window, and you're good to go. There's more that you can do, but that's the base level of what it can really happen. To take a quick peek at it, I popped this into our Mo viewer. I'm just going to go ahead and hit load manifest, and if we then take a peek, if I just select on one of the renditions, you can now see this is actually loading in as a live stream instead of just a normal Syntel. And we can control that. Everything goes through. Once again, works for TS, works for CMAF, and allows us to get all the information and replay streams and have live streams for testing whenever we want, which has been really handy for us as we do a lot of work within the player realm, a lot of ad work, client side, and so forth. So it's been a cool tool for us. We wanted to go ahead and start opening this up to everybody else who might potentially want it. In an early version, if you do, just feel free to hit us up. I put up a quick little link for bit.ly Demuxed 2019. You can put your email there. We'll start sharing access to anyone who wants this. The other tool in there was the Mo Viewer. That one allows you to do manifest monitoring on the fly. Pretty cool too. That one we opened up last year for users, and we recently added a bunch of cool new features. So anyway, figured it'd take a minute, show you guys one of the new tools that we're opening up for the video engineers out there, and if you want to start playing around with it, let us know how it goes. Thank you.
Good afternoon. This will be the opposite of my talk last year on the Content Fabric, which was long and theoretical. This will be very short and about the specific deployment. We were able to go live with it this summer in support of a premium content library from a Hollywood studio. And the title of my talk is streaming this library in this novel way of the Content Fabric using no CDN, no transcoding service, and no database. And instead of the database, an embedded blockchain ledger. The challenges this company had are common. They had many new opportunities to monetize their library, but a wide range of sort of ad hoc architectures for distribution with many CDNs, aggregators, et cetera. It was all very expensive to them and daunting. They're quality challenged, meaning that they could obtain broadcast quality over the air, but not consistently over the internet. Security challenged in that they had good authorization, but were leak prone. And also creativity and content they felt was limited by their technology. And while they have a very strong fan base community around certain of their franchises, they're unable to really capitalize on that due to the tooling that they had. So, if you remember back to my talk last year, the Content Fabric is a global software overlay network built in a very novel way. There are really 3 layers to its operation, which are spread in logic over host computers that run the fabric. That is a lowest layer of data, which allows for content to be sharded into binary parts over a network in a systematic way. Those parts represent the binary tracks, the metadata, and the code that allows for just-in-time rendering. Then, on demand, instead of a push architecture with pre-generated transcoding and rendering, on streaming demand, the content is actually assembled on demand over the network. That is, the parts are read, served through the network, code is applied to transcode package and do other accessory features, add insertion, et cetera, and a blockchain smart contract that is part of every content object's identity and also is the stateful mechanism in the fabric is applied to regulate access control. So with this in mind, this particular studio was interested in applying the content fabric as a single platform to basically replace their traditional stack of CDN, aggregator, and transcoding services. They were hoping to use this both for VOD and linear support, and they were also interested in bringing this through their supply chain so that they could support multiple properties that are global and also have to reach a range of mobile, web, and smart TV platforms. And this is just a very quick peek under the hood in the last 30 seconds. That is, the master content is actually ingested into the fabric either directly by copy or indirectly by reference. And the large majority of this company's content is actually on S3, so it's by reference. And the fabric on ingest creates content objects, which is the structural representation unique to the fabric that includes mezzanine level parts. Those shard through the fabric in a systematic way. And then on client streaming demand, because none of the streaming experience could be altered, Dash, HLS, Widevine, HLS, AES, DRM, those streaming clients on demand cause the fabric to generate.
Thank you, Michelle. We said it would cut at 3 minutes. Look at it. Thank you, Michelle. And next up, there's some good color balance there. Next up, we have Kevin.
I'm here to talk about wildfires, actually. I understand you guys have been having them too. It's a big problem in Australia. Lots of people get killed in bushfires. And what we're trying to do at Switch. Oh, here we go. So we talked to lots of people. And one of the guys called Lou works for the bushfire consultancy. And he basically said, you know, what is it we can do? He says, well, basically people watch videos if they think it's about them. And so what you do is you basically include clips of their local town, like the school, maybe local shops, things like that, something they're familiar with. And what we can do is at, next slide, please. Clicker. Oh, okay. And we mix that with live updates. So things like wind directions, what's coming next, how strong is the fire if it's nearby, and you get live updates. And next slide, please. Oh. Okay. And we also found that using a good narrator is a good idea. So if you got someone like David Attenborough or David Jones, someone like Morgan Freeman telling you should leave is a good idea. And there's a man engaged. Out you go, heading that way. Okay, so how it works. So Switch Media, we've got a product that we're working on. It's called VOD to Live, which takes in many clips that you already have, and we make that into a live linear stream. But we can also mix in other linear streams. So if they're on the same encoding ladder, we will include that. So what that's made up is, say, short clips from a general fire safety message, but then you interleave that with local school. But the narration is, someone like Captain Picard telling you, this is the danger that you're facing, and everyone gets that same message. But basically, the point is that you're making lots of old content new again. So basically, that's what it's all about. And then obviously the people, they just get a single link. It's only one link that they know they can go back to, and it's like a broadcast message that's going round and round and round on the carousel. How can you help? So basically, it needs to be rock solid. We can't just have something telling people to leave and they're having to reconnect. So we need it to work on HLS and Dash, which it does, but we also need to make sure that when we're doing standards and stuff like that, we think about how it fails safe correctly. It goes back to the lowest encoding in the ABR. I think that's largely it, basically it. That's what I had to say. Thank you.
Thank you so much. Thank you so much, Kevin.
Hi, I hope you guys can hear me.
Everyone. There we go. Hey.
Cool.
Well done.
So I'm here from Kubrick. We do a product which is able to show video as code. You're able to represent video as code. So it's sort of analogous to HTML or CSS. Since you're able to represent a website with that, we wondered why not a video as that. So this enables you to sort of declaratively define what all the interactions in the video might be, what the components are. So why would you do that? It allows you to have composability. you get to scale up very fast. So let's say you have one template, you're trying to create 1,000 or 10,000 different videos. How do you do that? If you have video as code, you can replace stuff within that code. At least that's the idea. And that allows you to sort of bring in automation and machine learning as well. Okay. Okay. So you can then sort of break up a frame into components. For instance, you have a frame here which has text, which has shapes, which has an image. And so you can sort of represent that as in this sort of thing. When you're trying to represent video as code, you have different components, like I mentioned, and each component can have its own meta information. For instance, if you have a rectangle, you could have size, position, color, stuff like that. So for example, this is sort of YAML. You have opacity, shape, you have position, you have a size, and so that renders this, just a simple orange rectangle. Another example, because you need to have animation for it to be fun. So this adds an animation block, which gives you something that moves. So from here, you can go to something which is a lot more complicated, where you have sort of an image which is moving around, hopefully, text which shows up, and stuff like that. Okay. So how do we do this? We have a video processing layer. We have a preview in the browser. So that is basically canvas HTML. We take that, we bring in some ML magic. That's where sort of the automation comes in when you want to create at scale. Since you have this sort of composition, you can bring in some ML here. So you have a config parser, you have a preview component, which is canvas. It provides you interactivity. There's a rendering pipeline. And I think I'm running out of time. Okay, so there's a bunch of machine learning techniques quickly. Thank you. Yeah, I'm the only one here, but there's a lot of people behind.
Hello, everyone. I'm Sebastian. I'm with Twitter, and I've been doing some great stuff in my free time at the expense of Twitter CPU power. First of all, a great shout out to this awesome blog post about rate control in Demuxed 264. I know a lot of our interns watch these videos, so I assume a lot of yours might also be doing this. Nobody teaches this at university, so a lot of students watches this, so it's going to be more like an introductory level presentation for rate control. So I'm not going to talk about constant bitrate. I'm not going to talk about single or dual pass average bitrate. I'm going to talk a little bit about CRF, which is constant rate factor, and I'm going to talk a little bit about VBV, which is the video buffer verifier. But mainly it's going to be about CRF. So CRF basically translates complexity in an image into a bitrate, and it kind of assumes that the quality is unique, or the quality for each CRF value is similar across all types of content. So if you stay with this assumption, then the question is, if you were to encode a large amount of video samples, and we're going to only apply the CRF factor in our encoding settings for a single resolution, how are things going to look like in terms of bit rates? So if you have a large amount of video content with different sort of complexities, then the bit rates are going to be all over the place, and it's going to be something more or less like this Gaussian. Now, the issue with this Gaussian is if you start changing things, then it's going to be relatively hard to compare. So I changed the Gaussian, or I translated the Gaussian into this cumulative density function, which basically shows the probability of the amount of video samples you might have at a certain bit rate. And I've done this not only for a large amount of video samples, I also made them into segments. So it's something like 5,000 videos with then split into 3-second segments. And I was wondering what happens if I just change the CRF value, which is what I did. And so what you see over here on the left-hand side are the high CRF values, which are the low qualities, which means they're relatively low bit rates. And if we change the CRF factor in steps of 1, we go gradually to the right. Now, Something not a lot of people know that TRF actually is a floating point value, so I didn't go to the whole search space, would have been like a really monotonic slide. But you can see over here that, for example, the distance between all those curves is not linear. So the bitrate actually is not shifting constantly if you change your CRF factor. So that's something I thought was interesting of sharing. Now the other question is what happens if you actually change your resolution but keep the CRF value constant. So that's what I did in a second experiment or a second test of my scripts. And on the left-hand side, you see a low resolution. The left-hand graph is low res. The middle one is medium res, and the right-hand is higher res. And you can actually see that the bit rates starts to be different. And if you actually do subjective testing, you see also that the quality increases for the higher resolutions. So basically, you can't just assume if you keep the CRF constant, everything is going to look the same irrespective of the resolution. So first of all, CRF has a nonlinear impact on the bit rate. It's resolution dependent, and if you go...
Yeah, that's the way it works. Thank you so much, Sebastian. So, Elbar, hopefully.
Yeah, thank you. I'm Elbar. I work at Purify. I'm an engineer. And I'm going to try and do something different. I'm going to try and do comic relief. You know, have fun for a minute. Tell some jokes about video. I'll be using my phone here because, you know, this whole thing was conceived last night. So, yeah, bear with me. Many people kind of chipped in and helped on this. So they are equally responsible. For the good and for the bad. I'm not going down alone. So you know who you are. I can see some faces. All right. What's a CDN's favorite pickup line? Do you cashier often? There's another version. Hey, nice cash. What is Megatron's least favorite streaming service? Prime Video. What's Russian's favorite streaming service? Netflix. Two video atoms are stuck in traffic. The first one yells, "Move!" That's an MP4 joke. Thank you. Thank you. Why did the video call 911? Because it was on Firefox. How do you know if an engineer is in video? Don't worry, he'll tell you. What's the difference between H.265 and H.264? 1. It's pretty obvious. Why did the CDN jump out of the plane? Because he's living on the edge. How do you know that your stream is not low latency? Ask your friends, they already know. Why is Dash going to be the most used streaming protocol? Manifest Destiny. It was suggested that this joke could be made about HLS, but no. HLS doesn't have manifest. It's a playlist. Where's the worst place to look for Dash streams in the wild? On Safari. Thank you, guys. Why did the B-frame cross the road? Because I had to pee. If you didn't get that, it means you don't support B-frame, so yeah. Just saying. Why don't audio and video seen together anymore? Because they got demuxed.
Thanks. I'm Lucas Pardew. I'm an engineer at Cloudflare. I work on things called QUIC and HTTP 3. Does anyone know the difference between HTTP 2 and HTTP 3? 1, yeah, great, cheers. So I apologize up front. I've been cheeky and I've asked for this slot because I purposely left something out of my slides that will be appearing later. But through some discussion yesterday, I figured it might just be of some interest to the room. So this is how we can use some open source software called Quiche and integrate it into curl or Nginx to actually run the new IETF QUIC protocol, or HTTP 3, in real clients and real browsers. So I'll be brief. We have a repo on GitHub. It's got some stars. Do check it out. The important thing here, which maybe isn't coming out there, is that this is written in Rust. And I know most people aren't rewriting their software in Rust. So we also have a nice C API that's pretty simple. And this is what we use in Cloudflare's Edge to integrate with Nginx. And we've been helping with Daniel Stenberg on curl to get this into Go. Right, so what do we have? We've got the code, we've got the docs. Go and check that out if you care. If you really want to try out curl, you can do this quite easily on a Mac. You can use brew, do this, and then make that request. It should work. And there's way more detailed instructions on how to do this from source. So if that's what excites you, go and try it out. Similarly for Nginx, we have a patch in the quiche repo that you can just grab a normal copy of Nginx, clone quiche, apply the patch, and build it with these parameters. There's way more information on our blog post, and we've got some more documentation there. So what I really want to see from people is to do this before my session, and then come and ask me some questions at the end of that. It should all happen pretty quickly, but maybe not. And that's all I have to say. I hope you look forward to the next session.
Good afternoon, everyone. Yes, my name is Cyril Concolato. I work for Netflix, and these are the slides that I presented at the AOM Research Symposium on Monday. I had 25 slides, so I will not go through all of them here, but if you are interested, I can show you the full length of these slides. So I want to talk to you about the AV1 image format, also known as AViF. It's an image format that was released earlier this year. The specification is available on GitHub. It's a specification, so it's a file format that is based on technologies you know. It's based on the ISO-based media file format, so boxes, and there's no move atom necessarily in this one. It's based also on HIF. HIF is the same technology that is used in your iPhones or tablets to store images. And it's based on MIAF, which is another MPEG standards. The capabilities of AViF are the capabilities of AV1 plus those of the file format. So you can do 8-bit, 10-bit, 12-bit. You can do lossless or not. You can do monochrome. You can do any color space. You can do chroma subsampling, all the chroma subsampling you're used to. You can do HDR and film grain, because at Netflix we like film grain. So an example of an HDR image here, you can't see much here on this screen, but I encourage you to actually go to our blog post and download these images, AViF images, and this open source tool to visualize HDR images, AViF HDR images. So we did some results. We did some comparisons between various codecs. So I have plenty of slides like this with different resolutions, different subsampling. But this is one that is quite interesting. As you can see on the rightmost column, AViF is performing pretty well compared to all the image formats that people are used today. So it's a very good format. We also tried to decode these images to see how good or bad it would decode, how fast it would decode. We used David, encoded 12,000 images, AViF, JPEG, JPEG 2000, and WebP. And as you can see on the left, AViF is performing pretty well. It's a bit slower than good old JPEG, but it's still good. So there are already plenty of tools to read and write AViF files. There's a library, open source, called libavif. You can download it, and it's simple. Purpose is to integrate it in your image pipelines. There are plenty of other tools, including players, and Chrome is integrating libavif. And so, in summary, AViF is a good format. Start using it.
Hi, I'm Jean-Baptiste. I'm the president of the Videoland Foundation. I'm working and managing VLC, X264, FFmpeg, and lately David, which are a lot of tools that you use day to day. Of course, I only work on open source projects. Here today, I'm going to talk about David. So David is the AV1 decoder that we created around Videoland because the idea was that we needed to have a good, fast decoder for everyone in order for the format to be successful. Because the hardware decoders are going to be shipped next year, and it's going to take some time for them to actually be everywhere. And we cared about being actually cross-platforms, very fast and small size. So I was here last year to launch it at Demuxed. The first release was last December, and today I'm releasing a new version, just after this talk. David is fast, and I mean very, very fucking fast. We're between 3 to 5 times faster than AOM DAC. Not 30%, 3 to 5 times faster. And as you can see, we've done it for SSE3, SSE4, AVX, and also lately SSE2. So very fast, and it's shipped already in Firefox and in Chrome and VLC and FFmpeg. So you're already using it when you play AV1 today. Click. We're also fast on ARM. So there is a new library called libgav1 from Google that is targeted on Android. Well, it's out and it's optimized for Android, but we're already faster. We're already faster, and we've on ARMv8, as you can see, we're 2 to 3 times faster. But where they focused on ARM32, we're already 2 times faster, and we've not finished our optimizations. What is interesting is that this shows the decoding complexity of AV1 compared to HEVC, and you see that David is at the same complexity than FF-HEVC to decode HEVC. Why is David faster, and why you're not going to be able to bait it? For 3 reasons. The first reason is that the C version with no assembly in single thread, we're faster than both libaom and libgav1. Then, our threading is better. Like, look at how we scale until 2048 threads. It's insane. Because David has a very weird both tile thread and frame thread at the same time. So that's why it's extremely fast and scales correctly. And the last thing is we use C, not C++, no templates, no C++ overhead. We don't use intrinsics, right? We use handwritten assembly. And like as you can see, most of the code in David today is assembly, like 25,000 lines of C, and now we are 35 of assembly, handwritten, of course. And so we are very fast, but we need to be faster. So we are looking at new stuff. And today, well, on ARM and on Android, you don't really care about being faster, right? You play your file, which is 60 FPS. So now you care about FPS per watt. And during the summer, we had a student who worked on doing the last part of David in shaders, on compute shaders. So, and you can see that we have a...
Oh, no.
There we go. Hey, everyone. I'm Jeremy Brown from Australia, 7 West Media. Here to talk about caption translation. But most of you might have seen me post way too much on LinkedIn, this logo. At 7 in Australia, we're lucky enough to stream some of the major sporting events. Next year, there's a big one. It's the Olympics. 300 countries, 300 events, 200 countries. It's going to set all kinds of records. Anyone involved with this at a CDN level or a player level or a broadcaster knows exactly what I'm talking about. It's pretty much all you talk about. This isn't the, anyway. So there are these odd sports, but then there's other ones. Home and away, if anyone knows about this, it's 80 countries, 7,000 episodes. It's been going on for 32 years. Oh no, they killed him. Oh, did anyone notice that was Chris Helmsworth?
Is this maybe the wrong deck?
Generating captions. So, cloud speech-to-text captions work. There's lots of providers out there that do this. Why are the errors so obvious? Humans are adaptable. We catch background noise, geography, accents. These things catch us. We can detect and they can't quite. But translating captions, now this is really interesting, and I got 1.5 minutes to get through this. Captions are text files, VTT. Text translation's been around for decades. Everyone's been doing it. So we built a proxy API that basically takes text translations, convert it to other languages, publish off the CDN. Pretty easy. Runs on cloud APIs. It's hugely scalable, super cheap. You pay as you go. 1 minute to go. The manifest that you normally would publish, you just add in all these other caption languages. It's pretty much no dev required. Thank you, VTT people. That was amazing. So these Olympic medals and electrocuted soap actors are shared moments. So, you know, we feel like this is a really good feature. Isla Fisher, Guy Pearce, Julian McMahon, Naomi Watts, Simon Baker, and Heath Ledger.
Hey guys, if you don't know me, I'm Phil. Among other things, I'm doing the AV this year. This is the wiring diagram and our little booth from 2018's Demuxed. The interesting thing from last year is kind of we had 2 different of frame types going around. It was relatively simple, worked pretty well, other than one slightly wacky HDMI cable. So I wanted to give a quick update on where we are this year. It's a little bit more complex. There are no less than 10 decimators, including the mystery decimator. I literally was sat there and went, there's 5 on this desk. What's this one for? Turns out we're using it to standardize one of the signals coming out of one of the cameras for a bit of a long SDI run. The really interesting thing here is we are using redundant Twitch ingest, so if the hardline goes down, which it did yesterday, we fail back over to some bonded LTE connections, which is great. We've got a big LED wall for the first time this year, so I actually wired this wrong. It doesn't go to just the LED wall driver. We've actually got then another machine processing that. Has anything interesting gone wrong this year? Well, probably the most interesting thing was some gear got rebooted this morning, and it kicked all of our staff Wi-Fi down, which turns out we were pretty heavily reliant on, so that was a bit of a pain in the backside. But other than that, no, it's pretty much same as last year. We've got some HDMI kit from ATEM, so actually a thanks to Facebook for lending us some kit, and obviously a huge thanks to Twitch to lending us all of the kind of the stream production gear and the cameras and everything you see around. So thank you to those guys. But otherwise, if you want to check out how chaotic it is over there, go have a look. Pull some random wires out, you're all good. And I have some time left. Wow. And next up is the next representative of London Video Technology. It's Kieran.
My name is Kieran. I'm going to be talking about RIST, which is a new protocol for video transport over the internet. So I'm not sure all of you were here 2 years ago where I kind of gave a half-an-hour presentation about some of these technical challenges for business-to-business video that traditionally once used to be done by things like satellite and private fiber and is now being done using the public internet. The public internet, unlike things like satellite and fiber, is lossy, and we need a protocol to handle such packet loss. And also in various locations, we need to be able to use multiple internet connections. In the US, for example, from AT&T, Verizon, etc. And we need a protocol that's capable of doing this. And it's generally UDP-based, so this will not end up being the same sort of technology as B2C content, so your Dash, HLS, RTMP sort of things. So my entire presentation name was kind of a lie. RIST is not really a new protocol. It's more of a set of guidelines around existing IETF protocols, such as RTP and RTCP, which, for those who aren't aware, are for just sending packets over the wire and sending retransmissions. The key thing being latency is bounded. You can say, between me and you, I want a delay of 100 milliseconds, and it will always stay 100 milliseconds across whatever links. What it does allow is interoperability. So each vendor can innovate on their approach, but it will still work. And this is kind of comparable to encoding. You can have different vendors have different encoder implementations, but you know the decoder will still work. So lots of companies in the marketing group. Probably the most interesting one, I think, is AWS. At IBC about a month ago, AWS enabled RIST in their Media Connect product. But there are also various other vendors and users. Software-wise and hardware-wise, there's 3 open source implementations at the top to choose from. And there are numerous other commercial implementations, including hardware as well. So I believe there are about 7 or 8 different independent implementations, so it's not a vendor-specific protocol anymore. One of the key things RIST does is really build on larger industries. There are much larger industries that use IETF standards, used by billions. You make a WhatsApp call, a FaceTime call. It's using RTP, it's using RTCP, but this is more constraining it for use in broadcast applications. We don't really need to do things like SIP and negotiation. Operationally, it's much more simple. You can literally do TCP dump and see what's going on, see if links are down, see RTP numbers, RTP sequence numbers, RTCP retransmissions. There's a next version of RIST. They're calling it the main profile. There's a key thing missing, encryption. You could do this at the network layer like we do currently, or you can do RTP with DTLS, key exchange, which is the way to do things. There's no custom key exchange, which is a bit dangerous, in my opinion. Also allows null packet removal and re-addition and extended sequence numbers.
Brilliant. Thank you, Kieran. Thank you.
Yeah, I just wanted to show some tool that I've been developing in my copious free time, let's call it like this, and how I got to develop this thing. So first, at some moment in my life, I just happened to be walking there, and they told me, hey, there's this video coding service. This is FFmpeg free. Do you want to work on it? I'm like, yeah, but I know nothing about video. I know about shell script, so that's how I started. It's very easy. Just do shell script. You try it, and then just check the ls there. It's just to see the size of the file. Then you play it. Of course, this doesn't scale very, very well. I don't recommend it. So we thought that we'd need a tool in which we could see media, the media properties. We could transcode on the fly, and we could compare video side by side. Now, of course, the problem is that I don't know video, but I also don't know web development. So this is pretty much what happens when you let the engineers decide the design. So I'm going to go over what these pieces mean, and maybe at the end it will make some sense. So what properties do we care about? So here it's a very, very basic thing. So it's like you're in Windows, you click properties, you'll see like the resolution, bit rates, and this kind of thing, duration. Now this, of course, it's not enough. And then we wanted, as we learned a bit more, we wanted to understand like the internal structure of the videos, all these kind of frames and the bit rates and this kind of thing. But as you use it more and you have more needs, then you understand that you really need to know everything, right? So we just get the media info, and we just dump everything because at the end, you're going to need it anyway. And then we want to transcode on the fly. So there was like some tweak there saying, hey, experiment with this video profile. And you basically click on it, and you will get a very, very easy way to run FFmpeg, right? So you will click on it, and it will generate this updated metadata with everything that has happened in between. And there's like two interesting learnings that we got. I don't think we would have gotten without this tool. First one, it's audio. If you see, everyone here uses very, very good video, but sometimes we produce really small videos. Everyone cares a lot about video size, but audio size also matters. So at this moment, we're like 20% audio for probably something that is totally, totally worthless. And the second one, it's the CPU time, right? So if we serialize the time used by several threads, then you know, I think it's very well known, right, that the threads have a penalty. So what we found is that just by tweaking this, we got, and setting to transcode with one single thread, we got 17% savings in compute, only by doing that. Okay, and then of course we have some side-by-side comparison with this comparator, and now you can point your phone, and then you would get the video, you would see how our customers see it, and now maybe you can make sense of that.
There you go. Out of time. Thank you so much. Fantastic.
So I'm Vittorio Giovara, and I work on the video encoding team at Vimeo. I'll present something about audio, and I'm good at compressing, but I'll do what I can in 3 minutes. So audio in the web is a solved problem, right? It's easy to encode, it does not use much computation, and the results are good. Yes, but you need to do it correctly, because audio is a very important part of the audio experience for your users, and it needs to be done correctly. There are a lot of options that you can have to deploy audio on the web. We can start from the one that you shouldn't use, MP3. It was one of the first codecs that used the psychoacoustic optimizations. That basically means cutting away frequencies that you can't hear. And it performs okay at a high bitrate, but it's very bad at a low bitrate. And it's nice because nowadays all patents that plagued the experience have expired. And you can use it on the web on all supported or major browsers, but as a progressive file, but don't. Your users deserve better. Vorbis is the next big codec. It was standardized a bit after MP3. There are a lot of improvements. And it's one of the first audio-free codecs. Can be encapsulated in OGG, because everybody uses OGG. And it's more importantly, WebM, so that you can use it with the MSE. AAC is the next big codec. It's a 97 award best codec acronym, because it stands for Advanced Audio Codec. And as the name suggests, it's very advanced. There are more sample rates, there are more channels. It's pretty good, and it's supported on any platform because it's basically free to use, so you can distribute AAC without no license. The only limitation is that makes it non-free is when you ship a binary, you need to have a license. And it's nice, it can be encapsulated in MP4 and works both in MC and HLS. One particular profile that is really nice is HEAC, another good acronym, stands for high efficiency. Adds two important tools, bandwidth replication and parametric stereo. And it's a good way when you are using audio in constrained bandwidth. And you just need to be careful when you're switching from a normal AAC profile to a HEAC profile because the context switching is noticeable. The one that is probably the best one is the Opus. It works well in every bitrate and any frequency. It can be encapsulated in MP4, so it's easy to use. Works in Chrome, in Android, in Firefox. They are supported. In Apple, it doesn't because reasons. And for my slide, I show that the bandwidth is Opus is always above everything, and so please consider adopting it and supporting it. Thank you.
Hello, everybody. So last but not least, dessert. That's what you want to get in the end, right? So SRT for ultra-low latency, live video contribution, distribution, blah, 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 yeah, old stories. SRT does fast file transfer. Yeah, I think I heard about that. Redundancy, main backup, seamless switching and bonding, maybe. Oh, keep talking, that's interesting. But what about we combine all of that together? Wait. What? Why would you do that? Well, because Colleen Henry from Facebook came up with the idea. So what this does is we combine low latency transfer, which SRT is, right, with a file mode, which has a message mode, where you can basically make sure that every message you send in gets exactly out the same way. So what if I put dash segments into the message and manifest into the message, the file path or whatever name the file has goes into the header of the protocol, you transmit it to the other side, and you utilize the bandwidth as much as possible on the way, which SRT is really good at. And you have ARQ and FEC to recover the packet loss, and you can bond the networks together for maximum throughput if you want to do contribution. The result of all of that is that you really achieve, as you can see on the graphic, a really nice, smooth network utilization exactly at the maximum bandwidth that you want to get. So this is obviously misusing like live methods for file transfer, but that way optimizing the network throughput and the utilization of your network. If you are interested in trying SRT file transfer, if you want to learn more about redundancy, the main backup seamless switching, which we added, and the bonding that is coming, if you're interested in DSRT, aka dessert, then check out the source on GitHub. There is a new experimental branch for the redundancy, main backup, and bonding code. And join the SRT Slack channel. There is a DSRT channel in there to talk about what I just explained to you guys. Thank you very much.